We're back. Here we go. The Cenozoic Era. All right. This is it. This is era of recent life. All 65 million years of it is recent. Truth is, we've come a long way. Here we go. Precambrian. Cambrian starts here, but we've been through all the Paleozoic, the Mesozoic, which contains the Triassic, Jurassic, and Cretaceous, and now we're in the Cenozoic. Cenozoic is nice and divided, the Tertiary and the Quaternary, third and fourth. Well, here, notice this, the Tertiary takes up 63 million years, and the Quaternary, 2 million years. Not evenly divided in what's going on. If Mesozoic is the time of the dinosaurs, the Cenozoic is the age of mammals. It's the age of mammals. It's also about flowering plants. Flowering plants take off. Angiosperms instead of gymnosperms. So flowering plants, fruits explode all across. So let's get into it. All right. By the way, there are a couple other charts show this long time ago, less recent, and the Cenozoic is here. Several of these divide instead of the Tertiary and Quaternary, they divide it a little differently. And I'm going to show you, this is new. This is the Chronostratigraphic Chart. This is the new international standard for naming all of this. So, yeah, Tertiary and Quaternary, there's Quaternary, but we took the Tertiary and we divided it into these two. But it's all still in the Cenozoic era. All right. Mesozoic is Triassic, Jurassic, and Cretaceous. Before that, Paleozoic goes all the way back, and then Precambrian for all the rest. That's be careful. Be careful with your dates over here. This is a million years ago, 11 million, 15 million, 20 million, et cetera, et cetera. If we put that into linear so that they're all the same step, all of this shrinks 7 million, 20 million, right? 60 million. And then Paleozoic. Most of the history of Earth is Precambrian, down here in this pink color, because all of that, it's over 4 billion years. Because if there's 4.5 billion years ago, the last 541 million years start with Cambrian and the Paleozoic. But Precambrian takes up 4 billion years before that. So you know. All right, what's going on with the land? Let's look at the land a little bit. So at the very end of the Cretaceous, Triassic, Jurassic, Cretaceous, at the very end of the Cretaceous, we're going to move in. We're going to play this. We're going to mute this. And we're going to see everything's kind of in shape. The landforms look like the landforms we're used to 50 million years ago. Now, India is making a bead. It hits Asia there. You get the Himalayan mountain range form. Northern North America, the Greenland is separating further from Europe. Alaska's doing some changing. South America's moving. Central America's being created. Now, real quick, watch this today, and there's going to be a blip, boop, ice age, and then back to today. Because this is in tens of millions of years. That little ice age was a blip on there. They just added it because we know more specific about it. Speaking of which, why do we don't look at that? Why do we know more? Why do we keep dividing and dividing and dividing all these things? Because we know more. You know, when you get into here, stuff's actually, well, not that long ago, but stuff gets written down. You've got history. We can look at the rocks better, and we know more about all of this than we do about any of this. It's just the way it works. Okay. North America, so we just looked at the land. North America, the Atlantic coast, the Gulf Coast, about the same. The West Coast, huge volcanoes, mountain ranges are being built, lots of changes, lots of plate tectonic activity. What else? So, by the way, we're still in the Cenozoic, and that chart naming group that I closed out on earlier. They're the ones who decide when these actually change. So, all right, life, mammals. So mammals overtake reptiles because what happens right here? Right here, what's the big dividing line? Meteorite. Meteorite hits the earth. Boom. Dinosaurs go extinct. Mammals spread and diversify because they don't have predators. They don't have to hide. So mammals stretch out. They grow. They do a lot of things. The angiosperms, the flowering plants were already starting to here, but then you had that big meteorite and all the climate change, the climate changing that happened with it, and they take off. And they spread wide. The other thing that happens, by the mid-tertiary, we're getting grass. Now that sounds weird because we've had algae and we've had seaweed and we've got all sorts of stuff, but you've got more ferns and stuff. You're getting grass and seeded grass. Once you get that, it spreads quickly, and then herbivores come about. So they're not just eating insects and eating other animals. Now you've got some strong herbivores going out, and they follow the spread of the grasses. And once you establish herbivores, then you can establish carnivores. Yeah, there were dinosaur carnivores, but the mammals, there weren't mammal carnivores until you had bigger, more widespread mammal herbivores. And it all just keeps following. One of the things that help the mammals start here. Okay, live birth. Live birth is risky compared to eggs, but you don't have to tend the eggs. You just have to tend the young. I get a trade-off there. But mammals have steady body temperatures. We are warm-blooded. We're able to regulate that body temperature, which means we can move into colder places, which means we can find food and we can hunt, not when it's the heat of the day. We can look all day. We can do dusk and dawn. We can work. The mammals can work at different times, and those are advantages they had over the reptiles, because the reptiles have to lay on the rock, get warm in the sun, and then they become active. Mammals are far more active than reptiles. Mammals also have, they started getting more thicker body hair. They can go into the colder climates, more efficient heart and lungs than many of the reptiles. They're active little things. They need the heart. They need the circulatory system to keep warm, etc. So, all right. Big picture, there are 4 major ways that mammals diversified after this meteorite die-off. All right, when the beginning of the Cenozoic, when mammals took over, they increase in size, they increase in brain capacity, they get specialized teeth. What do you mean specialized teeth? Like the herbivores get big flat molars and the carnivores get sharp canines. Like their teeth depend on their diet and their teeth change. They get specialization of limbs. It's the 4th one. All right, and it reacts to the environment. So, do you need a long tail? Do you need a short tail? Do you need short or long legs? Can you stand on 2 or 4? What do you need based on your environment? And so the mammals diversify in those 4 major ways. All right. What are some of the mammals? What are some of the, not even mammals, what are just some of the animals that are around? You ready for this? You're going to like this. Paracitherium. This is one of the largest land mammals ever in all of history. You can look up land mammals now and you'll get elephants. This dwarfs modern elephants by a lot. It's a hornless rhino, roamed parts of Asia through the early and mid Cenozoic. It's huge. You could see different modern rhinos, right? The 4 modern rhinos, and then 2 ancient rhinos. There were several things that were horse anteater like. You could see some of these faces that we're going to look through. All right, so there's another one. And then here is an ancient elephant. That is not a modern elephant here. All right, but again, head does not even come to shoulder height. Head barely comes to shoulder height. On an elephant, you walk up to an elephant, their shoulder is there. Let's see. Okay, that's fine. Sloth. Not a modern sloth, not a sloth. Ground sloth. Big dudes, like bear, right? Huge things running around. All right, what else do we get? Terror birds. South America had terror birds that roamed after the dinosaurs died. These guys stayed around, but they're this weird, or dinosaurs birds, or birds dinosaurs. Like, what? This is an odd thing. Huge, huge things. And there's all this article is all about how they hunted. Did they just chase you down and peck you down, or did they like shake you, or they like just jump and hop on you? Huge things. There's a good scale. Taking down a prehistoric hearse, the Titanus, the terror bird Titanus. It's huge. So, they lived all through South America. Cool. What do we got here? We got one more here. This is the not the group, kingdom, phylum, class, order, family, genus, species. It's like the class of terror birds. For Shusisade, I don't know. I got nothing there. But the extinction, the recent skulls, all the different terror bird versions. And let's see. Oh, no, that we don't need that yet. All right, last little thing. See, so the Cenozoic, lots of cool animals, but everything from saber-toothed cats, woolly mammoths, terror birds, ground sloths. Other things are starting to get towards what you would modern expect. There's all sorts of North and South America. If you really get into your geology and your history, North and South America, there wasn't a Central America. South America was an island, and it wasn't until you had some polar ice caps that lowered the sea levels that Central America came up out of the oceans and became a land bridge, and you had animals migrating south, you had animals migrating north. Terror birds migrated from South America, and some of not the big Titanus, but some of them were found, say, in Florida. And then other things were migrating south across the border. It's one of the biggest migration patterns, things going north and crossing each other on this little narrow land bridge of Panama. It's happened. All right. But I killed the tab about the timeline. You guys know the timeline. All right. Cenozoic. So early Cenozoic, right? So just several different things. New plants are evolving. Flowering plants are diversifying. The massive extinction of the dinosaurs. The first rodents, armadillos, primitive primates appear. They're all small. And they get, right, they've changed quite a bit. Now we're fast forwarding, so 50 million, only 50 million years ago. Rainfall, no seasons, no glaciers, still the temperature. So the seasonal aspect of Earth isn't what we would expect it to be now, right? Plants, flowering plants continue to diversify. Let's see. We're moving forward. We're drying things out a little bit. Warmer conditions. Grasslands are spreading, right? great migration of animals from continent to continent over land bridges. Abundance and diversity of land mammals is at its highest. So we've had some of the land mammals start to die back, or the species like become specific and not just so many. Armadillos, sloths, possums, porcupines moved to North America. All these things moved to South America. I don't want to just keep reading, but so then the Quaternary. So this is the most recent. This is important. The position of the continents are essentially the same as they are today. The outlines changed because of ice ages. Glacial periods, sea levels go up and down, right? Global cooling 2.6 million years ago, and warming with ice ages. That got into a cycle for a while. Cooling, warming, cooling, warming. All right. During at its maximum, ice was super thick across North America. Significant number of larger animals, mammoths, mastodons, saber-toothed cats, giant ground sloths. They did not all survive. The forests were dominant. When the climate cooled, grasslands expanded, etc., etc. Okay. Let's go back. What kicked off the Cenozoic? What separates the Cenozoic from the Mesozoic? Right here. Right here in the Yucatan Peninsula, that little spot right there. We are going to look at this image right here. This is the Chicxulub crater, and it doesn't look like a crater. It looks like there's a peninsula there, and you would think that, oh, the crater is this huge hole. No, that's the Gulf of Mexico. Right here on the edge of this peninsula, there is a crater, and it is dated to 65 million years ago, right when the dinosaurs went extinct, right when everything changed. And there's a layer of iridium rich. There's a layer of dust all the way around the Earth. This hit kicks up a lot of dust. Dust lays on every rock surface in the whole thing, and then it gets packed in and is just normal in the layers, right? Just another layer. That layer has a lot of iridium in it. Iridium is not very common on Earth, but it is common in meteorites. Those are some of the pieces that are put together to say this was the impact. This was the one that killed the dinosaurs. So, all right, what we have is, that's the Cenozoic. That literally brings us all the way into today. We're still living in the Cenozoic. What's going to be the event that changes to the next one? I probably don't want to know, because most of those events are catastrophic. So we're going to wrap up on time stuff. We're going to test soon. It's going to be available. And then we're going to move on. We've got erosion and weathering a little bit. We've got oceans. We've got weather. Maybe some ocean stuff. That's the rest of the year. So have a good day, and we will talk to you